class we have seen how to create a file, create a new file, how to access a file system in a Java application, how to create a new file, how to create a new folder, how to create hierarchy of folders, nested folders, and how to create a file in a specific folder. Okay, and how to represent the file system, how the path could be, and how we can change the properties of the file, and how we can verify the properties of a file. Okay, these are the basics that we have discussed in the morning class. Okay, now we'll see how to send some data from the Java application to the file system, as well as how we can retrieve data from the file system to the Java application. And first we'll discuss with the character data, and then we'll see the byte data. Okay, like non-character data like images, PDFs and all. Okay, let us see. The first thing is how we can send some data to the file system. Okay, let's consider like there is a file that exists. There is a folder test. In the folder test we have a file hello.txt. Okay, there is a hello.txt in the e files test location. Now let me represent the file system. Okay, otherwise let me not create a file. Let me not create a file. Okay, now what I'm doing is I'm creating a new file object to write some character content to a file. Okay, there is a class named file writer. The file writer constructor will take the file object as an argument. So to the file writer constructor we are sending the file object as an argument. So first we are creating a new file. Sorry, it is e files test with a forward slash or backslash, with a forward slash. Hello.txt. Okay, then just after creating a file writer, write method. Just please don't write now. We will be modifying this application after finalize. I will tell. Then you can note it down. Okay. To write the content into the file system, to write a character content into the file system, we use the method write, which can take a string like this is just I am writing some content into the file system. Once content is written to the file system, we need to execute the plus method. Okay, this is the basic application. We'll see why all these are required. Okay, we'll see individually why all these are required, but these steps are required. First create a file object, and then create a file writer on top of a file, and write the content of the file, execute the flush method. We'll see what the flush method will do and what all the things will do, but we compile the basic application Still cannot find the symbol file writer, just because even file writer is a class in java.io package. Okay, and the next error is what? Still unreported exception java.io exception. At which place it is giving IO exception? What are the lines the IO exception is being raised? Just see what are the lines the IO exception is being raised. 11th, 10th, 11th and 12th. Okay, at all the three places IO exception is being raised. Okay, now see, what is the 10th line? File writer. Now, what is the root cause for IO exception in this line? Which block has caused IO exception in this line? Which block has caused IO exception in this line? What is the executable block in this line? What is the executable block that exists in this line? Constructor of the file writer. So the first thing is the file writer constructor will throw. Invocation of a file writer constructor will throw IO exception. So whenever we execute the file writer constructor, we should handle IO exception. Understood? That's the first thing. Okay. Whenever we write or whenever we invoke constructor of the file writer, we should handle IO exception. So what I'll do is, in the try block, now if I catch, sorry, just I'm executing print stack trace. Now, will it compile successful? Let us see. Okay, the first 10th line exception is handled. Now again, what is it saying? Where the exception is? 18th and 19th line. Now, what is the 19th line? Now, what is the root cause for exception here? Write method. Invocation of write method of a file writer will raise a checked exception, which is IO exception. So, invocation of a file writer constructor as well as invocation of write method will raise a checked exception, IO exception. Now, I have put even write into the try block. Now let us compile. Now what is doing? Even flush is also raising a checked exception. So, flush. Whenever the purpose of the file is over, then we'll close the file. Okay, we'll close the file writer. Now whenever the purpose of the file writer is over, we'll close the file writer. Whenever the purpose of the file is over, then close the file. Okay, now let us see. What is giving? Close. File.close is not there, so not required. So we are executing file writer.close. Now what is giving? Unreported exception, java.io exception. Now even close method will raise a checked exception. So I have done here. Now, okay. First, what we are doing in the try block? First, before the try block, we have gone for a file writer. Why we have created file writer before a try block, I will explain later on. But before the try block, what I am doing is I am creating a file object. I am creating a file writer reference which points to null, and then I am assigning file writer to a new file writer object. The file writer constructor will throw a checked exception, which is IO exception. Okay, and the file writer write method is also throwing IO exception. Flush method also throws IO exception. Close method also throws IO exception. Okay, so I have kept all them in the try block. In the catch block, I am catching IO exception and printing the static trace. Okay, and now just once the file writer object is created, I am executing write method, executing flush, and closing the file writer. Now let us see what happens now. It was compiled successfully. Now let me go to the classes, execute application. Now let us see what happened to the file. Where it is hello.txt, right? Now is this the content that we have written into the file from the Java application? Yes. So this is the process how we can write a character content into the file system. Now let us see the individual blocks, why these are required. First, why file is required means file object is required to refer the path of the file. Okay, and file writer object is required to write the content into the file. So what we do is the file writer constructor will throw a IO exception. So we have kept in the try block. The catch block we have kept the IO exception. Is IO exception is checked or unchecked exception? Checked exception. Okay. And the write method will be used to write the content into the file system. We can write any content, primitive content, string content, character content. Any content can be written into the file system using a file writer. Okay. And what the flush method will do means the flush method will forcibly flush the content into the file system. And there might be some chances where the content will not be written into the file system if you don't execute flush. Because of some memory leaks or whatever the reason it might be, there is a chance that the content will not be flushed into the file system. Let me not execute flush. Okay, and let me remove the content of the file system. Now the file doesn't contain any content. Now let me go to the SRC. Compile the application, go to the classes, execute application. Now this is flushed into the file system, but if you don't execute flush method, it's not guaranteed, it's not 100%. For a number of reasons. Let's consider like in the middle of interaction of the file, the power has fluctuated. Something happened, the connection has been failed. Anything can happen in the middle. So the flush method will ensure that the content of the file will be, the content that we are writing into the file will be definitely written into the file system. Will be forcefully written. Flush method ensures that the content that we are writing will be written into the file system. So if you don't execute flush, what happens is it's not guaranteed. It's not 100% the content will be written to the file system. But if it is flush, if we execute flush with the file writer, then it is 100% sure that the file or the content will be written into the file system. Okay? So we should execute the method flush. We should execute the method flush. Okay? Whenever we are writing some content into the file system. Whenever we write the content in the file system, we should execute the flush. Okay? And whenever the purpose is over, whenever the purpose of the file is over, okay, then we should close the file writer. Now, let's consider that now, can we write the content into the file system? Can we write the content into the file system? Yes or no? No, we cannot write the content in the file system just because the file is read-only file. Now let me try to compile the application and execute the application. What it is doing? It's telling that the access is denied. Now, if there is some exception, there is some exception in the application at some line. Now, at which line it is giving the exception? 13. That means at 13th line it is giving the exception. Okay. Now, so just because the file is read-only. Okay. For a read-only file, we cannot write the content into that particular file system. Okay. If the file is read-only, then we cannot write the content into the file system. So make sure that the file is not read-only. Let me delete the file and let me create a new file and save it as hello.txt. Okay. Now for a read-only file, if the file is read-only, we cannot send some content from the application to the file system. It's not possible. Okay. If that is the case, while creating the file data itself, there will be some exception. Okay. And let's consider that otherwise let me have a null value and let us see whether null is written into the file system or not. Even I am not sure. Now I have a string which is pointing to null and I am trying to write the null content into the file system. Let us see how it will be. What is giving? Null pointer exception. Now at which line the null pointer exception is? 14th line. Now what is the 14th line here? Right method. But at this 14th line at this 14th line, okay, at this 14th line is the file writer object exists? Yes or no? Yes. Okay. Is the file exist? Yes or no? Yes. Is the file writer open? Yes or no? Now let's consider that. Okay, I am catching the exception. Okay, now there is a null pointer exception and I am catching the exception. Okay, now it is giving that there is a null pointer exception at the line 14. Okay, now if I print end, now is the content system.out.println of end printed? Yes or no? Yes, just because the exception that has been raised was caught. So end is printed and the stack trace is also printed. Now at the line 27, is the file writer still open or it is closed? Is the file writer still open or is it closed? Open, close. Still it will be open just because we have created a file writer, and while writing the content into the file system using the file writer, we had an exception at 14th line. But we are closing the file writer at the 17th line. But there is an exception at the 14th line. But let's consider like this happens for some 100 executions. 100 file writers are still open even though there is an exception and there is no use. Is it a correct thing? No. Now, can I close the file writer here? If I close the file writer here, now is it a valid thing? Yes or no? No. Why it is not a valid thing? If there is no exception, the file writer will not be closed. Okay? So now what is the best place to keep close? What is the best place? Finally block. Just because the finally block will be executed whether exception is raised or not, or the raised exception is handled or not. In any case, finally will be executed. So in any case, we can ensure that the file writer will be closed. Now understood the practical uses of finally? So in any case, if you want to execute some code, that code will be written in the finally block. The best example is closing a file system, closing a database connection. These are the setup kind of activities. All the setup kind of activities will be written in the finally block. So the close should be written in the finally block. So now will it compile successful? Definitely this will be a IO exception. Why it is a IO exception? The close method will raise a checked exception, IO exception, but it is not surrounded by try catch. So what I'll do is I'll check a condition in the try catch. Now let me execute close without try catch. So it will give a IO exception at the runtime, just because close method will raise a checked exception which is IO exception. So let me enclose this in try catch. Okay, and there is a catch. It is ideal thing to keep the stack trace also. Okay, now just compile and even it will be executed successful. End is printed, but the stack trace is printed here. Okay, now let's consider that let me make it read only. Let me again make the file read only. Now where it gives the exception? If the file is read only, where it will give the exception, at which line? 13th line. Then where it will go? To the first catch or the second catch? What was the exception that is being raised when a file is read-only file and if we try to write some content into the file? File not found exception. Now, is it a file not found exception? No. Now, where it will go? First catch or second catch? Second catch. But it will go for the first catch only. Just because file not found exception is a subclass to IO exception. File not found exception is a subclass to IO exception. File not found exception is a subclass to IO exception. So definitely it will go to the first catch. Then if I print system.out.println catch 1 and catch 2. Now let us see which one will be printed. Definitely catch 1 is printed just because the exception that is the exception that is raised in the 13th line is a file not found exception, okay, which is also a checked exception and which is a subclass to IO exception. File not found exception is a checked exception which is a subclass to IO exception. It is a java.io.file not found exception is a checked exception which is a subclass to IO exception. Now, so for that reason it will go to the first catch only. Now if I try to compile the application, go to the classes, execute the application. Now where it is going, the first catch or the second catch? First catch. Now is it coming to the end? Is it executing end? No. Why the controller has not come to the end? Just because there is a null pointer exception in the line 33. Why null pointer exception is there in the line 33? Why is there in the line 33? Now what is the root cause for null pointer exception here? What is the root cause for null pointer exception in the 33rd line? Huh? We are not? The file writer reference FW, while creating the object itself there is a exception. Okay? While executing the constructor itself there is an exception. So this statement is not complete. If this statement is not complete, still the file writer will have null. So for this reason, in the final block, it is always better to check the null condition. If W is not equal to null, then only close. After closing the file, it's a better thing to nullify the object. Why we should nullify the object? What's the use of nullifying the object? If you nullify the object, what happens is the object will be eligible for garbage collection. Once the purpose of the file writer is over, once we have written the content into the file system and the purpose of the file writer is over, then it is eligible for garbage collection. But it will not be eligible for technically it will not be eligible for garbage collection until it is nullified. Now, if we reach finally, is the purpose of file writer over? Yes or no? Yes. The purpose of file writer is over just because it has reached the finally block and already the content has been written in the file system and already finally block has been reached. So the purpose of the file writer is over. Logically the purpose of the file writer is over. But technically what happens is the object will not be garbage collected just because still there is a reference FW. The file writer object will not be garbage collected just because there is a reference FW. So now what we do is we'll modify to null, so that now what happens, the file writer object will become a transient object and it is eligible for garbage collection. This is one of the ways to increase the performance in applications. Okay, just whenever the purpose of object is over, then nullify the object, so that we can make the objects eligible for garbage collection, and we can increase the performance of the application. It is one of the performance tuning measures in the applications. Close the resources, nullify the objects whenever the purpose of the objects is completed. These two are some of the performance tuning measures in any software applications. Close the resources. Once the purpose is over, nullify the objects so that the object will become a transient object, and transient object will be automatically garbage collected. Understood? Understood why we should write the close method in finally, and why we should write enclose in a try catch, and why we should check for a null condition, and why we should nullify it after close. Understood all these things? Everybody? Now, once the file writer is null, make even the file to null, so that even a file object will be garbage collected. So nullification or closing the resources should be in the reverse order of opening. First we open the file, then the file system. So while nullifying or closing, we should do in reverse manner. First the file writer, then the file. So first we have nullified the file writer, then the file. Okay, nullification or closing the resources should be done in the reverse order that they have been opened. So first we have created a file, then the file writer. While nullifying, first we should do first file writer, then file. Like that it should be.
And sir, in the sense that we are not creating the empty file in the Java. And it is not possible to create the empty file.
It's possible. It's possible to create an empty file in Java. But why did you think that it is not possible to create an empty file in Java?
But actually we are writing some margin, and then it is not changing.
It is creating? Come again?
Actually we are writing some null values, but it is not changing.
Why? Because if you are trying to write some null values, okay, first it will check, okay, whether the string dot length is matching with the file length or not. We can fix the file so that it can have some maximum length. Okay, first it will match whether the length of the string is greater than the length of the file or not. We should see, we can write a very big string, but that may not be fitted into the file. First it will check the length of the string is greater than the possible length of the file system or not. But in order to check, the length method should be executed on the string. If you execute null length method with the null, what happens? Null pointer exception will come. So that kind of checks will be done in generally. So null values cannot be sent into the file system. Okay? But why did you think that we cannot create a empty file? See, here we are not creating the file. First of all, here we are not at all creating a file. We are trying to access the existing file to write the content into the file. To create the file, did you attend the morning class? No? That's what the problem is. So, try to refer the videos, you can understand it better. That's why I used to tell Java is a linking language. If you miss one link, it's really hard to follow the process. And is how the content can be written into the file system. Understood? And if you want to enter some new line characters, just we can write backslash n will give a new line character. In any software application, backslash n means a new line character. Okay? Sorry, it's a read-only file, right? So let me delete the existing file. Let me create a new file. Hello.txt, which is there in e files test. Now let me write some content. Hyderabad /n central /n university. So /n means it's a new line character. Sorry, we did not modify this. Okay, now I create a new file and let me execute the application. Sorry, file application, go to the classes, execute application. Now end is reached, and if you see the content, Hyderabad in one line, central in another line, university in another line. Just because the backslash n in any file system will be a new line character. Okay. In any file system, the backslash n will be a new line character. Okay, and to the file writer we can give the direct path also. File writer we can give the path directly. Even this is possible. No need to create an explicit file object. We can write the content to the file writer directly. Now Hyderabad Central University is printed twice, or just is it replacing the existing content, the whole content of the file system? Is it appending the content at the end, or is it flushing out the content and overriding the existing content? Overriding the existing content. It's not appending the content at the end. It is overriding. Okay? So we can represent a file writer directly. If you want to change the properties of a file, then we use the file object. If the intention is, or if the requirement is just to write some data or to write the content in the file system, then we need not to have a file object. Directly we can use a file writer itself. File object will be created only if we want to modify the properties of the file. If our intention is just to write the content in the file system, definitely directly we can use the file writer. Okay, file writer equal to new file writer of the path. So the file writer constructor is overloaded so that it can take a file object as well as it can take a string. The string can represent the path of the file. Then when we go for a file writer with a file object means we can create a file object and we can change the properties of the file. Then we can execute the file writer on top of the file. Okay? If our intention is just to write the content in the file, we need not to go for another file object. Just go for file writer directly. If we want to access the file, change the properties of the file, and then write the content in the file system, then go for file. Understood? Now, is the content that we are writing using a file writer, is it appended at the end, or is it overwriting the existing content, overwriting the whole file content? The whole file content will be removed and the new content will be there. But if you want to, okay, write the content at the end, we should go for a flag. Okay, let me see. The file writer constructor is overloaded so that it can take a boolean value. It can take a boolean value. The boolean value is a append flag. The boolean value is a append flag. That may be true or false. The default value is false. For an append flag, the default value is false. Since the default value is false, what happens is, whenever we write the content in the file system using a file writer, it will not be appended at the end, it will be rewritten. The existing content will be flushed out and the new content will be written. Just because the append flag is false by default. The file writer constructor can take a boolean value as a second argument that represents the append flag, and the default value for append flag is false. That means whenever we write the content in the file system, the existing content will be removed from the file system and the new content will exist, will be written into the file system, because append is false. If the append flag is true, then what happens? The existing content will be as it is, the newly added content will be appended at the end of the file system. Understood? Now let us see, by using append flag as true, what happens? Okay? What happened? At the end of the file, this is the end of the file. At the end of the file again, Hyderabad Central University is being appended. Okay? Like that it will be. Okay? So, the file writer by default is by default using a file writer, if we write the content, is it a appendable file or a non-appendable file? It's non-appendable. By default, the file writer is non-appendable. Okay, if you want to make the file writer as appendable, we should send boolean value true as a second argument. Then true means the file is appendable. So whatever the content that we use using write using write method will be written at the end of the file. The default value of append flag is false. So that by default the file writer is not appendable. The default value of append flag is false. So that by default a file writer is not appendable. Now, let me remove the file. File object is not required now. The file object will be created only if we want to change the properties of the file. Now what happens? Why do you think it is a compile time error?
The block we are prepared and we are
Hmm?
the file is defining our diagram, so we load it to the block and we are using the block.
So we have declared the file writer reference in the try block. So any local variable declared in the specific block will be local to that particular block. So if you declare the file writer in the try block, it will be local to the try block. Okay. So if you want to make it available throughout the exception handling mechanism, what we need to do? We need to declare before the try block. So he's telling that cannot find the symbol, cannot find the symbol. Why? Because just it is specific to the try block. So rather than making it specific to the try block, now what happens? Now can I access it in the finally? Yes or no? Can I access FW in the finally now? Yes or no? Definitely yes. Just because before try block itself we have declared FW. So FW can be used after this statement, after the NAND statement, wherever we wish we can use the reference variable of file writer. Understood why we have created it before the try block? Understood? Just because to access that in the finally we have created the reference to file writer before the try block and we have assigned the object in the try block. Understood? Now this is the ideal way of writing the content into the file system. Now if is not there, the file object is not there. So with the application, now we see here again Hyderabad Central University, again Hyderabad Central University. Like this we can write the content into the file system. Understood? Now file writer is a class that we told. Okay, the constructor of the file writer as well as almost all the methods of the file writer will throw a IO exception. And next let us see how one more thing is left. Let me close this file. Let me delete the file. Now there is no file with the name hello.txt in this location. There is no file with the name hello.txt in this location. Okay. Now let us see what happens. Okay. And is the file created? Now, is the file writer capable of creating a new file if the file doesn't exist? Is the file writer capable of creating a new file if the file doesn't exist? Yes. The file writer first it checks whether the file that we have represented exists or not. If the file doesn't exist, then the file writer will create a new file in that specific location and then write the content into the file. Understood? The file writer, what it will do means, first it will verify whether the file exists in a specific location or the file exists in a specific path or not. If the file doesn't exist in a specific path, first it will create a new file and then write the content into the file system. Understood? Now we have seen how to write the content, how to write the character content into the file system. Now let us see how we can read the character content from the file system. Okay? Now you have to read the character content. Let me comment out this example. Just I have cut the okay. I have commented the stuff. Now, how to read the content from the file system? Okay, to read the content from the file system, okay, we have a file reader. Please don't write. We'll be modifying the example as previous. Okay. Okay. First, what we do is we create a file reader object on top of a file system or a file object. Okay, like a file reader, what we can do is we can use a object of a file, the reference of the object of a file, or directly we can give the path. While creating a file reader, what we used to do, we can do using existing file object reference or giving directly the path. The same way for file reader also we can do the same thing. We can give directly the path of the file or existing file class object that represents the file system. Either way we can do. I am directly going for the path. Okay. Now I have declared I with 0, and what I am doing is I am initializing I with fr.read. Okay. What I am doing is I am putting this in parenthesis. If you put something in parenthesis, first it will be executed. So first the highlighted content will be executed. Now what is the highlighted content? I equal to fr.read. Now I will get the value that is written by the read method. If that content is not equal to -1, if that content is not equal to -1, then print the value of I. That's our logic. I'll explain this logic in detail. First, let us see the possible exceptions here. Okay? And how to handle those exceptions. So, what is the first possible exception? Sorry, it is a compile time error, just because even file reader is a class in java.io package. So, import first file reader. First file reader should be imported. And then, what is the next exception? What's the next exception? File not found exception. When the file not found exception is raised, why the file raised? Because of at which line the file not found exception is being raised? 10th line. 10th line is raising file not found exception. Now, this line is raising file not found exception. Okay? Since this line is raising a file not found exception, what is the possibility? Why a file not found exception is being raised here? What is the root cause for file not found exception in this line? What is the root cause for file not found exception in this line? No. Does the file exist in that location? Is the file exists in the location or not?
But at a combined
See, why it is a checked exception here means the constructor of the file reader will throw a checked exception, file not found exception, irrespective whether the file exists or not. It's irrespective to the compiler. If you are using a file reader constructor, definitely file not found exception will be raised, a checked exception. Now, what is the exception what is the checked exception that is being raised by file writer? For file writer constructor, it is a IO exception. For file reader constructor, it is file not found exception. File writer constructor will throw IO exception. File reader constructor will throw file not found exception. File writer constructor will throw IO exception. File reader constructor will throw file not found exception. So, let me make it null. In the try class. Now, what is the exception class that we need to keep in the catch? File not found exception. Just because the file reader will throw a okay. Now let us see. Is there an exception? File not found exception is also a class that exists in IO package. So all the classes should be imported. Even file not found exception is also a exception class that exists in IO package. So even we need to import that. So now what it is doing? Unreported exception. What is the exception? IO exception. Now, so let me keep it in the try block. Now will it be handled? Will it be handled or not? Yes or no? The read method is raising a checked exception which is IO exception. Now, can I handle IO exception with the catch of file not found exception? Yes or no? No. Now, will it be compiled? Yes, just because IO exception catch can handle both file not found exception as well as IO exception. But the catch with file not found exception cannot handle IO exception. Just because IO exception is a superclass to file not found exception. So, the catch with file not found exception cannot handle IO exception. But the catch with IO exception can handle both file not found exception as well as IO exception. Just because IO exception is a superclass to file not found exception. Okay. Now, which one do you prefer? Two catches, one for file not found and one for IO exception, or a single catch which is IO exception? Which one do you prefer? A single catch which contains IO exception, or two catches separately, one for file not found exception and another for IO exception? Anywhere in software applications, especially in Java, going for a specific cache block is always advantageous. Okay, the reason that we have discussed already in exception handling, why should we should go for specific catches rather than a single generic catch. Okay, so we should go for specific catches. Now, will it be compiled? No, just because the read method will throw a IO exception. So let me write another catch with IO exception. Okay, let me print the stack trace. Okay, now the ideal way is whenever we open a file to read or write, the purpose is over means we should close the file in the final block. Now will it compile successful? Will it compile successful? The close method of the file reader also will throw IO exception. So even the close method of the file reader will throw IO exception. So it is not compiling. So even the close will be surrounded in try catch. With IO exception. Okay. So whenever the file reader is closed, there is no use of the file reader. So whenever it is closed, soon after we should make it nullified. And the cache block, whenever we execute the cache block, just make it a habit to print the stack trace, so that whenever the exception is raised, you can come to know what is the stack of the exception. Understood? Now this is how we can write the content we can read the content from the file system. All the exceptions are handled. Alright? Now let us see the step-by-step process of reading the content from the file system. First, we go for a file reader reference and we create a file reader object where we are giving the path of the file, and we have a local attribute I whose value is initially 0. Now what we do is we execute the while loop. First what I am doing is I am executing fr.read first. Okay, what read method will do means the read method will return the ASCII character or the ASCII value of the character. Read method will return the ASCII value of the character. Using a file reader, we can read character by character, not the whole string. While writing, we can write the whole string at a glance. But while reading using a file reader, we should read character by character. We cannot read the whole string at a glance using a file reader. If you want to read the content from the file system using a file reader, we should do that character by character. Using a file reader, we can read the content from the file system only character by character, not the whole string at a glance. But while writing the content, we can write the whole string at a glance. But at the same time, we cannot read the whole content of the file system using a file reader. We should make it character by character. So first read method what it will do means it will return the ASCII value of the character. That ASCII value of the character I am storing in I. Now I am checking I is not equal to -1, and I am fetching the value and I am printing in I. I am printing the value of I. Understood? Now, understood what I have done up to now? It's not end, still there is some modification that we need to do. Understood up to now? What we have done? We have assigned the value of read to I, and this will be verified against the condition. I value is not equal to -1. First I am assigning a read to I, the output of read to I, and then I am checking whether the I is not equal to -1 or not. So, first let us see what is the value printed. Execute application. What are the values printed? 72, 121, 100, 114. By seeing this, can we understand what is this? This is the ASCII value of a specific character. In any software application, in any operating system, the ASCII is the same. ASCII value will not change from one operating system to another operating system. For capital A, there will be a specific ASCII value, which is the same throughout software applications. Okay, ASCII value will not change from one application or one software application to another software application, or from one operating system to another operating system. ASCII is the same. Now it is printing the ASCII values of the specific characters. Now, if you want to print the specific characters, what we will do means we can typecast it into char. If we typecast it into char, then we can get the specific characters. Okay? If you want to get the specific characters, then we need to typecast into char. So, if integer is typecasted into char, what happens is the ASCII value will be converted into corresponding character. While typecasting an integer into char, what happens is the ASCII value will be typecasted into the corresponding character. ASCII value will be typecasted into corresponding character. So I am printing the character that I have registered. Understood? Now let us see. Hyderabad Central University. If you see the content of the file, the content is the same. Hyderabad Central University. Now, when the value of I is -1 means, when the read method will return -1 means when the end of the file is reached. Okay? When the end of the file is reached, then the read method will return -1. If the end of the file is reached, there is nothing to read. So it will come out from the while loop. If the end of the file is reached, then the read method will return -1. The read method will return -1 if the end of the file is reached. Understood? This is how we can read the character content from the file system. And on top of a file writer or file readers, we have buffer writers and buffer readers. See, file writer is a class in java.io package, and file reader is also a class. Which is java.io package, and on top of a file reader we have java.io buffer writer. On top of a file reader we have buffer reader. Okay. The same thing will be done by file reader and buffer writer, and the same thing will be done by file reader as well as buffer reader. And what makes the difference? That we'll see. Buffer reader or buffer writer are use the same purposes of the file reader as well as file writer. And what makes the difference? That we'll see. And the buffered entities are called as high level file entities, like buffer writer, buffer reader. All the buffered entities are called as high level file entities, and the normal entities are called as low level file entities. The buffer reader, buffer writer, all the buffered entities are supposed to be high level file entities. Normal entities are said to be file writer, file reader. These entities are said to be low level file entities. Okay? And what makes the difference? Okay, how, let us see first how we can write the content into the file system. Already we have seen a reader, right? So first we see how to read the content from the file system using a buffer reader. Using a buffer reader, we'll see how we can read the content from the file system. And then after we'll see what are the differences. What makes the difference between file reader and a buffer reader. Okay, now first we have created a file reader. In the same way we create a buffer reader, and the buffer reader can be created only on top of a file reader. So the buffer reader cannot be created individually. The buffer reader should be created on top of a file reader. So buffer reader equal to new buffer reader of, see, a file reader can be created either by directly passing the path or on top of a file object, but the buffer reader should be created on top of a file reader. We cannot give the direct path to a buffer reader. File reader should be created on top of a file reader. Buffer reader should be created. We cannot create a buffer reader without a file reader. So let me use the buffer reader to read the content. In place of file reader, now I am using buffer reader. Buffer reader will be closed, then we should close the file reader also. And then we should nullify the buffer reader first, and then the file reader. The order should be in reverse. First we open the file reader. First we open the file reader. On top of the file reader, we have opened buffer reader. While closing or nullification, it should be reversed. First we should close the buffer reader, then after file reader. We should nullify the buffer reader first, then after file reader. Understood? Now, please don't write. Still we need to modify. This buffer reader should be imported. It's a class in java.io package. We have not imported that. Okay. Now it was compiled. Go to the classes. Execute application. Hyderabad Central University. This is the same thing that we have done. But what makes the difference between a buffer reader and a file reader? Okay? Means the basic difference and the very first difference between a buffer reader and a file reader. Not even, this is not the only difference between buffer reader and a file reader. Between any low level file entity and the corresponding high level file entity. It's not the difference only between buffer reader and file reader. It's the difference between any low level entity and the corresponding high level file entity. Let's consider like difference between buffer reader, file reader. Difference between file writer, buffer writer. The difference is the same. What the difference is, okay? If we use a low level file API like file reader or file writer, the whole content will be flushed at the time or the whole content will be retrieved at the time. Okay? The whole content will be flushed at the time or the whole content will be retrieved at the time. Which may cause memory leaks. That means, let's consider like there is a huge content that we need to write into the file system. There is a huge content that we need to write into the file system. Let's consider like there are 100 boxes with us. Okay? There are 100 boxes with us. Okay? If we want to carry all the 100 boxes at a time, let's consider like there is some 1 kilometer difference and there are 100 boxes with us. And what our intention is to carry the 100 boxes from this place, from X place to Y place in a minimal time. Which approach will you follow? Okay? 10 iterations with 10 boxes at a time or all the 100 boxes at the same time? Which, let's consider like we have 100 boxes with us. Okay? 100 boxes with us. And we need to carry the 100 boxes from X place to Y place and the distance is 1 kilometer. Then which one you prefer? Carrying all the 100 boxes at a time from X to Y or carrying 10 boxes at a time from X to Y? Which one you will prefer? Obviously, definitely the 10 boxes at a time will be preferable. Just because if we carry all the 100 boxes at a time, the load will be heavy so that we may not handle. So what we do? To make it faster and more reliable, we take 10 boxes at a time and come back. 10 boxes at a time and come back. But if you want to compare this file reader to the buffer reader, this file reader will be like carrying 100 boxes at a time. The buffer reader will be like carrying 10 boxes at a time. So what the buffer reader will do means, the buffer reader will not directly read the content from the file system to the Java application. Whenever, if it is a file reader, what happens is, whenever we execute the read method, it will hit the file system and it will load the content from the file system. That's what the read method will do in case of file reader. But in case of buffer reader, what happens is, okay, in case of buffer reader, let's consider like this is a file and this file contains ABCDE. ABCDEF. Let's consider like the content of the file is ABCDEF and the maximum buffer size is 2 bytes. this example, let's consider like the maximum buffer size is 2 bytes. Okay. Now, what the file reader will do is, for whenever we execute read method, what it will do, it will pick up each and every character from the file system. Am I right? Yes or no? Yes. So, if you go for a file reader, what the file reader will do is, whenever for each and every character, it will go into the file system and it will fetch content from the file system and it will fetch. For the second iteration, go to the file system, fetch the character. Third character, go to the file system, fetch the character. Fourth, go to the file system, fetch the character. Fifth, sixth. Now, to read 6 characters, what are the number of network flows, or what are the number of interactions, or what are the number of interactions between the Java application and the file system? 6 iterations, or 6 interactions are there from the Java application to the file system to access the content of the file. Let's consider like the size of the buffer is 3 bytes, and we are accessing the same content using a buffer reader. What happens is, okay, the buffer reader, what it will do, it will go for a temporary buffer, a temporary cache kind of memory, a temporary memory. Let's consider it is a temporary memory. So, what it will do is, it will not have a network flows between the Java application and the file system every time. What it will do means, it will have a temporary memory. The buffer reader will maintain a temporary memory where it will, whenever we execute read method, okay, read method will fetch the content first from the buffer. If the content doesn't exist in the buffer, then it will go to the file system. Now, is the content exist in the buffer? Yes or no? No, the content doesn't exist in the buffer. So what happens? The content will be fetched from the file system. So, what is the buffer size here? 3 bytes. So, what the buffer reader will do means, it will fetch the maximum number of bytes from the file system into the buffer reader. What is the maximum possible number of bytes into the file system? Into the buffer, sorry, into the temporary memory, into the buffer, 3 bytes. So, it will fetch all the 3 characters. And it will fetch the first character. Okay. Now, for the second read method, now, is there any character in the buffer? Still? Yes or no? Yes. Still we need to read B and C. If all the characters are read from the buffer, then it will go to the file system. Now, are there still some characters to be read? Yes, B and C. So, you go to buffer, read B. You go to buffer, read C. Now all the characters are read. Then all the characters are read. So what happens is, then now there is no character to be read in the file system, in the buffer. So what it will do means, it will go to the file system and it will fetch the latest content and it will wipe out the existing content. Okay, and the next content will be D. So E, F. Now in this process, what are the number of interactions between the Java applications and the file system? What are the number of interactions between the Java application and the file system? Only 2. And which one do you think it is better? Definitely, buffer reader will be better if the size of the file or the content of the file is high. Just if you want to read 10 or 20, 15 characters, it's not advisable to go for the buffer. Buffer is advisable only when if you are trying to read the content whose size is very high, at least optimum. If the file size is very less, it's not advisable to go for buffer reader. Buffer should be used only when the file size is at least optimum. Okay? Yeah, what's the thought?
But buffer reader only is file reader. So, the data in the file should be inserted through file reader only.
No.
Because in the buffer reader,
the buffer reader will get the properties of the file reader object. See, file reader is created and it has the path of the file. Buffer reader, what it will do? It will just get the properties of the file reader and create a new object. That doesn't mean that the buffer reader internally makes use of file reader to access the file system. It's wrong. That assumption is wrong. Buffer reader internally doesn't make use of file reader to access the file system. But while creating a buffer reader, to set the properties to the buffer reader, it will get the properties from the file reader. Understood? Understood how it will be? How the buffer reader will work? By interacting with the files that have large content. Always it is advisable to go for a buffer reader to read the content from the file. That's the first advantage of buffer reader when compared to file reader. But if the content of file is very less, 20 bytes, 30 bytes, 50 bytes, that is the case, then we should go for file reader only. Just because it can be retrieved in a single shot. But if the content of the file is very high, then definitely we should go for a buffer reader. And then, now, are we reading character by character or the whole line? Character by character, am I right? But using a buffer reader, we can both read by character as well as we can read the whole line. Now, how we can read the whole line using a buffer reader? There is another method in the buffer reader which is read line, which can read the whole line. The same thing, I'm not modifying anything. In case of -1, now I am giving null. The read line method will give null if the end of the file is reached. If the end of the file is reached, then read line method will return null. Otherwise, the read line method will return a string. The return type of read line is a string. Just observe the difference to the previous example and the current example. Read method is returning an integer which is the ASCII value of the character. Read line method is returning the whole line of the file. And the read line method will return null if the end of the file is reached. Just compare the previous example with current example. The previous read example with the current read line example. You can understand the difference. Understood? Now, let me try to execute the application. So, in each line, Hyderabad in one line, Central in one line, University in another line. Is that the way that exists in the file system? Yes or no? Yes. Understood? How we can read line by line using a buffer reader? But this cannot be done using a file reader. Using a file reader, we can read only character by character. But using a buffer reader, we can read content character by character or even line by line. But this cannot be possible in case of file reader. File reader, using a file reader, we can read only character by character from the file system. But using a buffer reader, we can read both character by character as well as line by line until the end of the file is reached. Now, what are the differences between a file reader and a buffer reader? What's the first difference? The first difference should be it's a low level, that's a high level. File reader is a low level file entity, whereas buffer reader is a high level file entity. And this is the very most important difference. The way how the buffer reader retrieves the information and the way how the file reader retrieves the information. The buffer reader will maintain a temporary memory where all the content will be fetched into the buffer, then from the buffer to the application. First from the file system to the buffer and from the buffer to the application, so that the number of network flows or the number of interactions between the application and the file system will be reduced. Understood? You have this diagram in your notes, right? Make it as a second difference. Okay? The third difference is the thing that we have done just now. By using a file reader, we can read only character by character. But using a buffer reader, we can read character by character as well as line by line. Understood? Now, understood everybody? This is how we can interact with character files using a file writer, buffer reader, file writer, buffer writer. The same thing can be done by using a buffer writer also.
The file reader was calling memory purpose. File reader was calling memory purpose.
Manual?
Memory leak.
Memory leak. That's the example that we have discussed here itself, right? Within this, that also will come. Okay? And the same thing can be done even for the file writer also. Just I'll tell the example in the commentary section. Just it will be the same. First we'll go for a file writer object. And we go for the buffer writer. Okay. And using the buffer writer, we write the application. Just if you want, you can note down this up to this. This is enough. Just note down the basic concept and import even buffer writer, which is there in IO package. The remaining is the same for file writer and buffer writer. We need not to discuss, it's a waste of time. sorry, this buffer writer dot flush. In the final block, first close the buffer writer, then the file writer. Nullify the buffer writer, then the file writer. That the same way that we have done in case of readers. Close the buffer reader, okay, then close the file reader. Nullify the buffer reader, then nullify the file reader. In the same way, writers also. Okay, now we shall see how we can read the content from a what we call from a non-character file. Let's consider like we have an image file. Okay, how we can read the content from a image file into the Java application. We shall see that. Okay, now to read the content of non-character files, or to read the non-character content, or to write the non-character content, okay, in the perspective of file system, okay, all the non-character content is considered to be a stream content. Stream content means non-character content. All the non-character content is said to be a stream content. So how we can read the information from a non-character files, the image file or PDF file or anything. Okay, let us see how we can do that. Now, to interact with streams or to interact with non-character files, we should have streams. We should have streams to interact with non-character files or stream files. There are several streams available to fetch the content from the file to the Java application. To fetch the content from the file to the Java application. That means in order to read the content from the file to the Java application. Okay? What we use is, we use a file input stream. A file input stream. Okay, I have imported the file input stream. Now, let me use a file input stream. Shall I comment this? Shall I comment all this? Now even I have commented all this stuff. Okay. Now let me remove all the stuff. There is nothing here now. Now let me create now let me go for some file, some image file. Let's consider like on the desktop we have tutorial.pdf. It's very large. Right. Let me have this file, some file. This is a non-character file. Okay. Let me make it simple. Test.jpg. Okay. So okay, what is the location? Otherwise, let me put in the same folder rather than getting confused. Let me put the image in the same folder, which is e files test.jpg. Let me make it simply image.jpg. Okay, so let me name it as image.jpg. Okay, now same thing. It's not the byte content, it's not the character content, so we cannot expect the specific values, but it's a byte content. Our intention is to see how many number of bytes are there, how many times the while loop is executed. Not sure will it work or not. Let us see. Please don't write. Please don't write. First of all, we should handle all the exceptions. Make it int because there's first of all, the exceptions are with the file input stream. The file input stream constructor will throw a checked exception. What is the checked exception? File not found exception. That means all the constructors that read the information will throw a file not found exception. So let me make it null in a try block. Okay, and the cache block with file not found exception. Instructors. Okay. Print stack trace. Okay. Now this file input stream constructor is throwing a checked exception, file out one exception. We have handled that. Now let us see. The next exception is IO exception, which is caused by read method. So even we should catch that IO exception which is caused by the read method. Okay, and the finally block. This will check if now is there an exception? The close method also will raise a IO exception. So we should keep this in try catch. I'm executing print stack trace. Now let us see. Was it compile? Go to the classes, execute application. There are several bytes in the application, in the image file. Unlimited bytes. Okay. What I'll do is I'll iterate the count. I equal to 0, and each and every place I'll iterate the count. Okay, and at last I'll print the value of y. First, let me go for I here. What I'm doing is I'm initializing I with 0. And in each and every iteration of the byte, I'm counting the, what is called, incrementing the I. So what happens at the end of the iteration? Okay, now is I equal to the number of bytes present in that file? Yes or no? Yes. I will be equal to the count. I will be equal to the number of bytes present in the image file. Okay. Now. The ASCII characters 0, 3, 4 and all. $39, 832 is the number of bytes present in the file. Let us see. Is it the same? Yes or no? Yes. So that's how we can read the content from the file system if it is a non-character content. Okay, the same way but the entities are different. File input stream now in the same way, rather than using file input stream, And I think a read method is overloaded in the file input stream. Let me see. I'm not sure about that. Um, yes. Read method can take bytes. Let me have a byte array. Let me have a byte array of 100. Okay. Now the byte array is, the size of the byte array is 100. Now we can go for a byte array like this. Now what happens is, okay, 100 bytes will be read in a iteration. Rather than reading each and every byte in a iteration, we are reading 100 bytes in a single shot. 100 bytes in each and every iteration. Now how many times, let's consider like, this is the file, this is the size of the file. How many times it will be iterated? 398. 399 times. Just because 398 and there are still 32. For reading those 32, again once it will be iterated. So totally, rather than iterating 39,000 times, now we are iterating the whole content in 399 iterations. Okay, like that we can read a single byte as well as an array of bytes from the file input stream. Okay, a single byte as well as array of bytes from the file input stream. Now the read method is overloaded so that it can take an array of bytes. Now this array ARR contains the first 100 bytes. In the second iteration, 100 to 200 bytes. Third iteration, 200 to 300 bytes. Like that, 100 bytes are iterated, are fetched in each and every iteration. In each and every iteration, the 100 bytes are fetched. Rather than fetching one byte in the iteration, we can fetch multiple bytes or any number of bytes using a byte array. But this is possible only in case of input streams, not in case of readers. Okay, so let us see how many the number of iterations are there. Let's see how many number of iterations are there. How many iterations are there? 399. So 398, the previous example. It was overridden. So 398 plus the remaining bytes. So totally 399 iterations we have read the whole file rather than going for 39,000 iterations. Understood? How we can read the content of the non-character or stream files? Okay? In the same way, file input stream, like a file input stream, we can have a buffered input stream also. Okay, a buffered input stream will be created on top of a file input stream. First, I have gone for a file input stream. Let me import the buffer input stream. So I have imported the buffer input stream, and I have created a buffer input stream on top of file input stream. Okay, and I'll use a buffer input stream. First buffer input stream is closed, then file input stream. Then buffer input stream is null, then file input stream. So we see in reverse order. The same way, same like buffer reader and file reader. We go for buffer input stream, file input stream. The difference also will be the same. The difference between file input stream and buffer input stream will be of same like file reader and buffer reader, except the read line method. Leave out the read line method. The buffer concept is the same in any file class or in any file entity. File input stream, buffer input stream. File input stream, what it will do? In case of file input stream, now we are reading 100 characters at a time. Let's consider like the buffer size is 1000 bytes. Buffer size is 1000 bytes. Then the number of interactions between the file system and the application will be 39 itself, or 40. But here the number of iterations between the file system and the application is 399. If you use a buffer which has a size of 1000 bytes, what happens? Still the number of interactions between the file system and the Java application will be reduced. Understood? Understood? So that's how the streams will be useful. But overuse of streams is harmful. Definitely. Just because unnecessarily we use streams which will maintain a buffer, which will maintain a temporary memory. There are hundreds of users, thousands of users, then it is really harmful. We should use buffer only if it is mandatory and only if we are reading files of high size. Okay? Unnecessary usage of anything will be harmful. Unnecessary usage or over usage of anything will be harmful. Whether it is a software application or in a real-time environment, anywhere. We should use anything based on the requirement. Okay? The file size is very less. If you go for a buffer reader, but then it is a necessary wastage of temporary memory. It will eat up a memory of the application. If the memory is reduced, then the performance of the application will be reduced. It's unnecessary. So, if we are reading some content which contains, if we are reading from a file which contains a large information, the file size is very high, then go for buffer stream. Understood? Let's end up the day. Tomorrow at the same time, okay, we'll discuss how to write the content, how to write the non-character content into the file system. Okay? Then after, once this is the basic thing. Write the content, read the content. Write non-character content, read the character content. These are the basics. Once these basics are over, then we will switch over to serialization. Okay? A very important concept in file handling. If they are supposed to ask something in file handling, definitely 90% the question will be on serialization only. How serialization will be done? Why serialization should be done? It's that much important. It's not like these are not important. This may be asked, but whether the interviewer focuses on these things or not, on these basics or not, if he wants to ask some questions from file handling, definitely there will be a question on serialization. Okay? That much important it is. Tomorrow, in the first half an hour, we'll discuss how to write the content, how to write non-character content into the file system using file streams. Okay? Then after, and one more thing, these streams can be used to interact both with character data as well as non-character data. Okay, that's very important. Streams can be used to interact both with character files as well as non-character files, or character data as well as non-character data. But readers and writers should be used, will be used only for character content, only for character files. Okay? Let's consider like PDF files or image files cannot be written or cannot be read by a file reader or a file writer. But we can use streams, okay, to read or write both character data as well as non-character data. Okay? But in case of readers and writers, they can be used, they are specific to character content. But streams are not specific to character content, they can interact with any files, character files as well as non-character files. That's important. Okay? Some people will think like streams are supposed or streams are specific to non-character content. But it's not correct. Streams are generic. They can be used for any files. Okay? That's fine enough for the